This is the 10th lecture of the series Bracket Algebra. First, a brief touch on the topic discussed in the previous lecture 9. We discussed the triangle law of ket, namely norm of ket A plus norm of ket B is greater than or equal to norm of ket A plus B. In explicit terms, we can rewrite the relation as under root bra A ket A plus under root bra B ket B is greater than or equal to under root bra A plus B ket A plus B. We also discussed triangle law of vectors, namely mod of vector A plus mod of vector B is greater than or equal to mod of vector A plus vector B. It is now time to discuss Cauchy Schwarz law. We first discuss with respect to vectors. Consider two vectors, vector A and vector B, and let theta be the angle between vector A and vector B. The lengths are mod of vector A, also denoted simply by A, and mod of vector B, also simply denoted by B. Consider the dot product vector A dot vector B equal to AB cos theta. This can be written as cos theta equal to vector A dot vector B divided by AB. This is equal to vector A by A dot vector B by B. Take modulus to get mod of cos theta equal to mod of vector A by A dot vector B by B. For collinear vectors, suppose this arrow represents vector A and this arrow represents vector B. So the two vectors, vector A and vector B, are similarly directed, same direction and sense, and are collinear. They are on the same line. Obviously, angle between them is theta equal to 0 degree. Also, cos theta equal to cos of 0 degree equal to 1. Collinear vectors can also be represented differently. Say this arrow is vector A and this arrow is vector B. So the two vectors, vector A and vector B, are oppositely directed, opposite direction and sense, but are collinear. They are on the same line. Obviously, angle between them is 180 degrees. So cos theta equal to cos 180 degrees equal to minus 1. Whatever the case be, in both the cases, mod of cos theta is 1. Let us put instead of cos theta what we got, that is mod of vector A by A dot vector B by B equal to 1. This means mod of vector A dot vector B equal to AB, which we write using mod sign as mod vector A into mod vector B. This is an important result expressing equality involving vectors. For theta not equal to 0 degree or 180 degree, mod cos theta is less than 1. Let this arrow represent vector A. The projection of vector A is A cos theta, where theta is this angle and this arrow is vector B. Let us put for cos theta mod of vector A by A dot vector B by B. It is less than 1. This is recast as mod of vector A dot vector B is less than A into B. Written using mod, we have the left hand side less than mod vector A into mod vector B. This is an important result expressing inequality involving vectors. Combining, we write mod vector A dot vector B is less than or equal to A into B, or we write it as mod vector A dot vector B is less than or equal to mod vector A into mod vector B. This is an important result expressing both the equality and inequality involving vectors. Let us repeat discussion with kets now. Consider two kets, ket A, ket B. The norm or length of the kets are norm of ket A equal to under root bra A ket A and norm of ket B equal to under root bra B ket B. Suppose ket A and ket B are linearly dependent. This means ket B equal to alpha into ket A, where alpha is a number, may be complex in general. From this relation we get bra B equal to alpha dagger bra A equal to alpha star bra A, since a number dagger is equal to the number star, star representing complex conjugate of the number. Consider the quantity under root norm of ket A into norm of ket B. This is equal to under root bra A ket A into bra B ket B. Now bra B is alpha star into bra A. So the left hand side is equal to under root bra A ket A into alpha star bra A ket B. As alpha is a number, it can be placed anywhere, and so we shift it here to get under root alpha star bra A ket A into bra A ket B. We can write alpha star bra A as bra B to get under root bra B ket A into bra A ket B. Now bra B ket A is bra A ket B star. This is because bra A ket B star is equal to bra A ket B dagger, which is bra B ket A, since a number star is equal to the number dagger. Here star means complex conjugate. Hence the left hand side is under root bra A ket B star into bra A ket B. We thus have under root norm of ket A into norm of ket B to be equal to under root mod of bra A ket B square. This is obviously equal to bra A ket B. Let us write it changing sides. So bra A ket B equal to under root norm of ket A into norm of ket B if ket A and ket B are linearly dependent. This relation corresponds to the equality relation between vectors, namely mod of vector A dot vector B is equal to mod of vector A into mod of vector B for theta equal to 0 degree and 180 degree. Since the scalar product bra A ket B corresponds to the dot product vector A dot vector B. If this is not so, that is otherwise, the relation will be bra A ket B is less than under root norm of ket A into norm of ket B. That corresponds to the inequality relation between the vectors, namely mod of vector A dot vector B is less than mod of vector A into mod of vector B for theta not equal to 0 degree or 180 degree. Combining the two relations, we have bra A ket B is less than or equal to under root norm of ket A into norm of ket B, or we can write more explicitly bra A ket B is less than or equal to under root bra A ket A into bra B ket B. This corresponds to the relation between vectors, namely mod of vector A dot vector B is less than or equal to mod of vector A into mod of vector B. This relation is called Cauchy Schwarz relation. We end this video posing the question, what is Graham-Schmidt orthonormalization relation? We shall discuss this in the upcoming lecture.